Okay, so let's start today's class. Today we will talk about mathematical physics. And okay, so I have taken the NEET paper as I already told you. So let's start from the first one. So this is the question, first question. Can you see the screen? Yes, right? The screen is visible? Okay. Okay, so the first question is the element of a 3x3 matrix A are the products if its row and column indices Aij equals to Ij, where I equal Ij stands for 1, 2, 3, and the eigenvalues of A are how much? So you can see the question number. This is 34. So it's that part B question. So what will be the answer for that? Let me write something. It is written that the element of 3x3 matrix are the products of its row and column matrices Aij equals to Aij equals to Ij, right? So if I write here Aij, then it will be simply Ij. What does this means? It means that our A is a 3x3 matrix. It is already mentioned here. So this is a 1, 1 element. This one is 1, 2 element. This one is 1, 3 element, right? Then here, so the element of Aij will be 1 into 1, 1 into 2, 1 into 3, something like that. Now what will be here, the value? The value will be, here see, you can see here, 2, 1 element is there. So 2 into 1, then here 2 into 2, here 2 into 3. Similarly, here 3 into 1, 3 into 2, 3 into 3. Right? So if I just write it like 1, 2, 3, 2, 4, 6, 3, 6, 9. Now you can see it is nothing but a symmetric matrix. 3 by 3 symmetric matrix. They are asking that what will be the eigenvalue for this matrix. Right? Yes. The eigenvalues of A. Now I just want to tell you one thing. Just you can note it right down also. Only that much you have to remember. For a symmetric matrix, the eigenvalue is 0, 0, trace of it. You can prove it with the help of any type of symmetric matrix. So now for this case, you can see 1, 2, 3, 2, 4, 6, 6, 9. This is a symmetric matrix. Right? So what will be the eigenvalue for that? Eigenvalues will be, I don't want to calculate the Cayley-Hamilton theorem and all these things. So what will be the answer? 0, 0, and trace of it. Then what will be the trace of it? Trace of n is 1 plus 4 plus 9. Sorry?
For symmetric matrix, I don't think because the eigenvalues are here. I think the rank of the matrix is 0,
I can't hear you anything.
Eigenvalue. No.
Hello? Can anyone hear her? I can't hear. If you have any question, you can put it in chat box also, because I can't hear anything. Eigenvalues of symmetric matrix as well are the fine. Well, I think this only applies to matrix with rank 1. Which one? This one? Whatever I am telling that 0, 0 and trace of A. This, no, these are Hermitian matrix. Eigenvalues of Hermitian matrix are here.
Then I can give you one example of a symmetric matrix which is not, which does not follow this rule. For example, if you take any other symmetric matrix, I even solved one yesterday. 4, something like 4 minus 14 minus 12, then minus 14, 10, 13. 1. Yeah, for this eigenvalues will be minus 6.89, minus 9.64 and 31.54.
It should not be that one. It should be 0, 0 and 15, isn't it?
Okay, ma'am, I will check. Thank you, ma'am.
You have to check this one. This should be there because like every symmetric matrix need to follow that rule that 0, 0 and trace of A. Just check once, okay? I will also do that one.
The determinant of this matrix is not equal to 0. Only if the determinant, the product of the eigenvalues is equal to the determinant of the matrix. So if you see, for example, first one, 4 into 10 minus 13 square. For the first determinant. So automatically it will not be equal to 0. And
no. Determinant means only first one you are checking, that is not the correct one. Determinants with whole you have to check.
Similarly, if you check the whole thing, okay ma'am, I'll check. Thank you ma'am.
Just check once, okay? If it is not, then we will check again. Okay, so for that case, what is the answer? That will be 14, right? So it will be 0, 0, 14. Now, let's see the answer. This one will be the correct one. I'm taking a screenshot of that one also. I will check that. Obviously, it should be there. But yes, still. Okay, fine. Now come to the second question maybe. Or it is fine, right? Because the main point of this question is like we have to check the eigenvalues of a symmetric matrix and it will be 0, 0 and trace of A. And this one is fine. AI is equal to IJ. This is nothing but a symmetric matrix formation. Okay, now come to the second one. This I have taken from same question paper. And the question number is 36. The solution of a differential equation, this one with the boundary condition, this is how much? It's a little bit straightforward question. So maybe you all can do that one. I'm just going this one very quickly. If you have the answer before me, then you can ask me, you can write it in chat box. So this is the differential equation, and what is the boundary condition? The boundary condition is while x equals to 1 equals to 0. Now calculate. So how to calculate? dy dx plus 1 plus x by x y e to the power minus x by x. Right? Now here you can see that p is like 1 plus x by x. This is this form. Dy dx plus py equals to q. And this p is the function of q, x, and q is also a function of x. Right? So now what will be the IF here? Can you tell me what is the full form of IF? Does anyone know? Sorry?
Integrating factor?
Integrating factor. I'm just asking you. Simple. Okay. So what is the what will be the integrating factor here? E to the power integration p dx. Right? So what is p here? 1 plus x. So IF will be integration 1 plus x by x dx. Now what will be the answer? You can see here that integration 1 plus 1 by x dx. So e to the power x plus ln x, right? Now I can write it like e to the power x e to the power ln x. Then e to the power x is there and e to the power ln x will be what? Can you tell me what is e to the power ln x? X. So simply x e to the power x. So this is if. Now what we will do? Here dy dx plus 1 plus x by x y equals to, what is that? E to the power x by x minus x by x. So we have to multiply that if from both sides. So x e to the power x dy dx plus x e to the power x 1 plus x by x y e to the power minus x by x e to the power x. Now you can see this one will be simply ddx of y x e to the power x, and the right hand side will be how much? Simply 1. Then y x e to the power x will be simply x plus c1, right? Now the boundary, then y will be what? 1 by e to the power x plus c1 by x e to the power x. Now we have to write the boundary condition. Boundary condition was what? Y is equals to 1, 0. So we have to put that one. Y is equals to 1, 0. What is the meaning of that? When x equals to 1, y will be 0. So we have to put that one. Y will be 0, 1 by e to the power 1 plus c1 by 1 into e to the power 1. Then what will be the answer? E to the power minus 1 plus c1 e to the power minus 1. Now you can see e to the power minus 1 should not be 0. So 1 plus c1 is 0. c1 is minus 1. Right? Then what will be the y? Y will be e to the power minus x e to the power minus x plus 1 by x minus e to the power minus x. So e to the power minus x 1 minus 1 by x. So if I just write like x minus 1 e to the power minus x, right? Then what will be the option? X minus 1 by 1 x. Let me check this. X minus 1 by x. Option A. Good. Because we have to just calculate the differential equation with respect to integration dx e to the power. So this will be if, and we have to multiply that one, and we can get the value of y. Just put the boundary condition, and we can have the proportionality constant also, then we can get the answer x minus 1 by x or minus 6. I think it's understandable. Okay. So now we can go to the next question. Next question I will be taking the same from the same year. The question number is 48. Okay. The time evolution of a coordinate. Now see the 48. 48 means it should be a little bit more elaborated. The time evolution of a coordinate x of a particle is described by the equation this. For omega greater than a, the particle will how much? How it will behave. They are asking this one. The time evolution of a coordinate x of a particle is defined by this one. Okay? Now firstly I am just going to write here. So firstly I am just going to write here the expression d. It should be d4x, okay? Because here dt4 is there. So d4x, dt4 plus 2 omega square, d2x, dt2 plus omega to the power 4 minus a to the power 4 x equals to 0. First of all I have to write here because there is no space. What? Omega square dt2 plus omega square minus omega to the power 4 minus a to the power 4 x equals to 0. Now this is, you can see that this is a fourth order differential equation, right? d4x, dt4, something like that. So we have to simplify that one. How to simplify? Let me write here like that. X equal to the power m, mt, right? I'm writing like that. Then d4x dt4, what will be this one? M to the power 4, right? So similarly d2x dt2 will be m square. So m to the power 4 plus 2 omega square m square plus omega to the power 4 minus a to the power 4 equals to 0. I think you all understand that one. Basically it will be to the power mt also. Here also a to the power mt. But when we are putting here, then e to the power mt will cancel out from both of the term. Now this one will be the answer. Now you can see here, this is a very simple equation. I can write it like m square plus 2 omega square m square plus omega to the power 4 minus a to the power 4 equals to 0. Right? Then what will be the value of m square here? Okay. M square, I can write it like 2 omega square m square plus omega to the power 4 equals to a to the power 4. I can write that one. Right? Then what is this one? This one is simply a plus b, if I write it like a plus b whole square. Fine. Then m square plus omega square will be plus minus a square. So what will be m square? M square will be plus minus a square minus omega square. Okay, that means m square, two options will be there. One will be a square minus omega square and minus a square minus omega square. Okay. Now this m square is little bit lengthy, so let me write it here like u simply. Then u will be a square minus omega square and minus a square minus omega square. Now, okay, fine. Then what will be m here? M will be plus minus root over a square minus omega square and plus minus root over minus a square minus omega square. Now if I write like that, let me see. Plus minus root over minus of omega square minus a square. I can write like that. It is also I can write it minus of omega square plus a square. Then what will happen? Plus minus I root over omega square minus a square. Similarly here plus minus I root over omega square plus a square. Do you understand? Because I is root over minus 1. Now our m is this one. Now what was m previously? M was x e to the power mt. So x was e to the power mt. Now if I put like okay, then what will be x here? X will be e to the power something, but if I put the same value, I plus minus omega square minus a square into t. Then again this one plus minus I root over omega square plus a square into t. Now we can see one thing. What they are asking? They are asking that for omega greater than a, the particle will behave how? Eventually come to rest at the origin, eventually drift to infinity at x equals to infinity, oscillate above the origin, eventually come to rest at omega by a or minus omega by a. So I am just telling the last one first. So eventually come to rest. Come to rest means x will be 0. Now let me check omega by a point or omega minus omega by a point. Now you can see omega by a will give this one as 0, but this one will not give us 0. And even if it is 0, e to the power 0t, that will come as 1. So x will not be 0 at omega by a or minus omega by a. I hope you understand. So this one will not be the correct one, the D option. Now come to the third option. Third option is oscillate above the origin. Sorry. Can anyone tell me, after which you have heard, like this one you heard that the last option is not correct. Okay, someone is writing something. So can you start for me? Is it visible for others? Is it? Okay, visible. Fine. Can anyone confirm me that this one was explained or not? Because at that time maybe I was...
No ma'am, you were discussing option C, I guess.
Okay, so D was already discussed because I discussed D first and after that I discussed C. Okay, otherwise I can discuss again also. So the D option was eventually come to rest at omega by A or minus omega by A. Okay. Something is there. Okay. So we were with this expression. Yes, you can see the expression here. If our if our m has the value this one, then x will be this one, and if our m is be this one, then our x will be this one. So either both of them, if I put omega by a will be omega by a condition, then omega by a will give this one will be 0, but it will come as e to the power 0, but e to the power 0 which come as 1, it is not equal to 0. So that means whatever the, and obviously if I put here omega by a, obviously there will be no 0 term. So that means omega by a or omega minus omega by a will not give us 0 value. So the D option will not be the correct one here. Eventually come to rest at this one is not correct. Now come to oscillate above the origin. Now you can see that this is nothing but an oscillatory expression. E to the power plus minus I omega square minus a square into t. Or so is this an oscillatory expression or not? Obviously it is an oscillatory expression. So this expression C is the correct one because this is an oscillatory expression. Now even we have to come to the B and A, eventually come to rest at the origin. It will also not come to rest at the origin. Eventually it drift to the infinity, x equals to infinity. That will also not be correct one. So we can tell that it will be a oscillatory behavior at origin. So the C option will be the correct one. Now I think the time has already gone too much, so we can go to the next question quickly. This one also I have taken from this same question paper, and this is the 56 one. See, this is 56, that means this is a part C question paper, right? Now come to the answer question. If the Newton reduction method is used to find the quantitative of the equation, the iteration equation will be how much? You can see this is a part C question, but it's a very simple question. So just do that one quickly. If x equals to 2 sin x, then what will be the fx here? Fx will be x minus 2 sin x. Okay. Now for Newton reduction we need another one thing, but we need f prime x. What will be the this one value? Cos x. Now you have to tell me what is the Newton reduction method, iteration expression. Can anyone tell me what is the Newton reduction iteration expression? Am I audible? Hello? Am I audible?
Yes.
Can you tell me? Newton reduction iteration expression? Okay, fine. I am going to tell you. X n plus 1 equals to x n minus f of xn divided by f prime xn, and the condition was also there one, that f prime xn should not be equal to 0. So you can see that the f prime xn is not equal to 0 here. So now simply we have to write the values xn minus, what is fx? Fx is x minus 2 sin x. xn minus 2 sin xn divided by 1 minus 2 cos xn. This is the iteration expression for this question. Now there is a little bit solution, so we are going to solve that one. 1 minus 2 cos xn. Now we can see xn minus 2 xn cos xn minus xn plus 2 sin xn. Xn will cancel out. Then what will be the answer? 2 sin xn minus xn cos xn by 1 minus 2 cos xn. Okay, so this will be the xn plus 1. Now we have to match that one. In between a and b the answer will be there. This one is the correct one. So B option will be the correct one. This is simply one. We have to just put the value expression of Newton reduction iteration expression, and then if xn we have to put, then we can get the answer. Okay, I hope you understood. Okay, then we can go to the next question. This is from December 2019. Okay, this is a simple question. It is the question number is 42. The values of A, B for which the force acted is conservative. I think all of you can do that. So just do quickly. I should not put this type of question here because it's a very simple one. Okay, fine. For relaxation. So for conservativeness, what should I do? What is the condition of conservative? Curl of f equals to 0. So curl of f means I, j, k, del del h, del del y, del del z. Now write axy plus z cube, then x square dx z square, x square dx z square, that will be 0. So now do quickly. This will not be the non-zero part, this will be 0, this will be 0. So I will have the 0 1 for j, 3z square minus z square, sorry, bz square, 3z square minus bz square plus k cap will be 2x minus ax equals to 0. So what will be the value here? Simply we can write here 3z square minus bz square will be 0, b will be 3, 2x minus ax is 0, a will be 2. So now we can summarize a equals to 2 and b equals to 3. So if I check the correct one, equals to 2, b equals to 3. Okay. Now we can go to the next question. Next question also I have taken from December 2019, and the question is this one. This one is 64 question. Now see 64. 64 means it is also a part C question. The positive value of polynomial this one is determined using initial option method. Using initial case, let the estimate after 2 iterations be x2. The percentage error x2 minus 2 by 2 into 100% is how much?
Yes, ma'am.
So have you heard about this question or not? Because I think at that time the internet has gone. Okay. So this is the question from December 2019. So the question number is 64. The positive 0 of the polynomial fx equals to x square minus 4 is determined using introduction method. Using initial case x equals to 1. Let the estimate after 2 iterations be x2. The percentage error this one is how much? So let me write that one. So whatever it is given, fx is x square minus 4. So now something is there. Association order. Okay. Previous question was not that much difficult. I can show you the previous question. See the previous question. Maybe you have seen that question at least. The values of E and B for which the force this one is conservative. So simply what we need to calculate, curl of F equals to 0. Right? Then if I do the curl of A, then the answer of A and B will come as A equals to 2 and B equals to 3. That's it. Is it fine? What should I do again? Because it's a very simple one. So you can see that one, that values of I have calculated this one also. See I, J, K, then this. Then you can see here 3z square minus z square b plus 2x minus ax equals to 0, and then b will be 3, and from here a will be 2. So a will be 2, b will be 3. Simple. Okay. Okay. Now previous to previous, I think you were there. This one you were there, right? That Newton Raphson method. I think you were present, you people, or at that time also I was disconnected.
Yes, ma'am.
It was there. Okay, fine. Now we will go to the next question quickly. This one. So here they are asking, it is also again the Newton Raphson method, right? So here fx is x square. So here fx equals to x square minus 4, and they are asking that the x, okay, they have also given that x0 will be 1. They are telling that what will be the x2 minus 2 by 2. This is nothing but how our x2 is differ from the actual value. You can see x square minus 4 means the actual value will be 2, right? So how it is differ from x2, 2. So what should I do? Obviously, if fx is there, without any thinking, I will do that f prime x. What will be the value? It will be 2x. Now first x0 was 1. So what will be x1? x1 will be x0 minus f of x0 divided by f prime x0. Right? So x0 was 1, 1 minus. Okay, f of x0. If it will be 1, then 1 minus 4 minus 3 divided by 2 into 1, 2. So 1 plus 3 by 2. That will be 5 by 2. Okay? Now x equals to 1. If initial condition, then I get x1 equals to 5 by 2. Now they are also asking that x2, because we need to calculate this one. So for that case, we also need to check x2. So x2 will be what? x1. I'm just using different notation, but it is the exactly same one. I understand. I hope you understand. So it will be f of x1 divided by f of f prime x1. So now f of x1 will be x square minus 4. Okay, x1 there minus 4. So x1 was what? 5 by 2. So 5 by 2 whole square minus 4. It will be 25 by 4 minus 4. That will be 4. 25 minus 16, 9. Now f prime x1, it was 2 into x1. So 2 into 5 by 2, 5. So now x2 will be 5 by 2 minus 9 by 4 by 5. So it will be 5 by 2 minus 9 by 20. So the answer will be like 20, 50 minus 9. So it will be 41 by 20. Now they are asking this one. So what will be this one? 41 by 20 minus 2 divided by 2. So the answer will be 41 minus 40 divided by 4. So this is 1 by 4. And they are asking this term basically. So what will be the answer? 1 by 4 into 100%. So it will be simply 2.5%. Okay? So now go to the answer here. 2.5 means the option number D. So I think you understand. For this case, we have taken introduction expression x n plus 1 equals to xn minus f of xn by f prime xn. Now fx is given here, f of xn, f prime we have calculated, and they have given that initial base x equals to 1. So by putting x0 will be 1, we have x1 value. From that x1 value we got the x2 value. Now x2 minus 2 by 2 they are asking. So we have calculated. After calculating the value of x2, the term x2 minus 2 by 2 what? Into 100%. Then we are having the answer that it will be 1 by 4 into 100%, which is 2.5%. So for this case, what we need to remember? We need to remember this one. Nothing else. f of xn divided by f prime xn. And the condition will be f prime xn should not be 0. Here what was the f prime xn? The f prime xn was 2 into x. And 2 into x was not equals to 0. Then our condition is satisfactory. And the introduction is good here. And the fx was x square minus 4. I think you understood that one. Okay. Then we can go to the next question. Okay. So the next question, let me see if it works. Okay. Next question from June 2000.
In the previous question,
Tell me.
argument by 20 minus 2 divided by 20 in the last question.
Sorry.
In the last,
You are talking this one?
yeah, I'm getting a different LCM now.
Oh, your LCM is different? See, this is 20. Sorry. Oh, sorry, sir. Sorry. You should tell me, right? Thank you. That will be 40 and this is 40. The answer is correct. See, if it is 100 into 40, then it will be 2.5%. Sorry. You should tell me, yeah. That is 2.5%. Now it is fine, right?
Yes, ma'am.
Yeah. Fine. Okay, now we can go to the next question. Okay. Actually, this is not exactly from mathematical physics. This is from the electromagnetic wave traveling question. But yeah, we can also put it in mathematical physics question also. See that question number 29. So here, E is this one. Which of the following vectors is a value choice for EGM? So how to do that? E vector is E0 cos x plus 3y minus omega t. So here, this is an electromagnetic wave. So electromagnetic wave means obviously we have to follow this rule that if our E, D and K will be perpendicular to each other, right? So this is the main motivation. So we need that motivation only. So they are asking that what will be the value of E0 here. Now what to do? Our E was E0. Then what was the cos 2x plus 3y minus omega t. Cos 2x plus 3y minus omega t. Now see, this is nothing but k dot r, right? So k dot r means what is k here? I have already explained that one previously also in twice or thrice in the classes. So k will be nothing but 2i cap plus 3j cap. Now we know E and K are perpendicular to each other. So what is the condition? E dot K should be 0. Right? Now E dot K should be 0. Then what is the thing, like E may be, let's say, Ex I cap plus Ey j cap. Then E dot K, that will be 2Ex plus 3Ey. Okay? So now see the options here. I'm just going directly to the option. Our K was, from this expression, it was 2i cap plus 3j cap. And our K dot E should be 0. So which condition will be the 1? K dot E. If I calculate K dot E with this one is 2, this one is 1, 2, then this one minus 9 by 2, so it will never come as 0. Simply we can see that if it is 3, then we have to have a denominator like 3. So these two options can be the correct one. Now come here, 2 into 2 plus 2, that means it is coming as 4. So this one will also not the 1. Now see this one, K dot E. Now if I write here 2 minus 3 into 2 by 3. So it is coming 0. So this one will be the correct one for that. We can also do that one from the expression also. From this one also we can do that. Simple. Same thing. But I have given that one from the direct option also. Option means you can see that if it is 3, then in j cap in the denominator should be 3, otherwise there will be a fraction. Okay, so now you can see that the denominator will be 3, and this denominator, if 3 is there, then this 3 will cancel out, and then 2 will be there, and 2 minus 2 will give the 0 answer. So for that question, the main thing is that we need to know that K and B are perpendicular to each other, and I have calculated K, and then B will be such that K dot E will be 0. Here we are not talking about B because we don't need B in this calculation. Okay, so maybe I can skip to the next question. June 2020 question again. This one you have to tell me. The eigenvalues of the 3 by 3 matrix M is how much? Because we have already discussed this one from the first question. You have to tell me. Option yes, good. Because here 0, 0 and trace of A. Trace of M. Trace of M means A square plus B square plus C square. Okay, very simple. Okay, fine. Now come to the next question. June 2020 again. Okay, this one. A function of a complex variable z is defined by the integral this one, where gamma is a circular contour of radius 3, centered at origin, running counterclockwise in the w plane. The value of the function at z equals to 2 minus I is how much? So we have to calculate this one instead. So let's calculate. And what is the gamma here in the w plane? At the center, I think. At the center the origin is there and the radius is 3. It is like that. It should also be 3, but yeah, and it is counterclockwise. So now our fz is, I can write here fz, w square minus 2 w minus z dw. So now you can see okay, so here w minus z will be 0. This is a pole, right? W equals to z or z equals to w. This is the pole, isn't it? Yes, this is the pole. So if it is a pole, then you can see if I am putting w will be 0, then this point will give a singularity. See, 1 by 0, something by 0. So now our pole is at z equals to 0 or w, because w and z are same here. So now at that point, what will be the residue? At z equals to w, something is there. Oh, sorry, again the internet was disconnected. Again the internet was disconnected. I think you have heard these things or not?
No, ma'am.
Again, yes. Okay. So this was the function, and they are asking that what will be the value of that function at z equals to 2 minus I point. And they have option B. Option B. No, option B is not correct. Okay, I will tell you. Fine, no problem. Don't do it now. So here, what I told here, fz is this one, right? So now our pole will be at which point? W minus z equals to 0, right? So now at that point the residue will be how much? W minus z into, let me write here clearly, residue at W equals to z point is limit W tends to 0, W minus z, W square minus 2, W minus z. Then the answer will be W square minus 2. Now here they were asking that z will be 2 minus I, and at this point W and z are same, so z was 2 minus I point. So at that point 2 minus I whole square minus 2. So what will be the value? 4 minus 1 minus 4I minus 2. Then see here, 1 minus 4I. This is fine. 1 minus 4I, but we have to multiply that one with 2 pi I, isn't it? Because fz will be that will be 2 pi I into 1 minus 4I. That we should to remember, okay? Then it will be 2 pi I plus 8 pi. Now see the answer. 8 pi plus 2 pi I. This one. They are asking that this function value. They are not asking that residue value. The residue will be 1 minus 4I. But the function value will be 2 pi I into this one. So 8 pi plus 2 pi I. Is it fine? I hope so. Okay, so the option will be C. We have to multiply that one with 2 pi. Okay, then we can go to the next question, June 2019. Okay. This one is the part C question. The free energy of a magnetic system as a function of its magnetization M is this one, that we are nuclear positive crystals. At a fixed value of A, the critical value of B, above which the minimum of A will be at, our non-stop value of magnetization is how much? I think the time is not that much, but we can do it as a homework also. What we need to do? A is there. Okay. Now, what we will do first? They are telling that what will be the minimum of AF will be at non-zero value of magnetization. So obviously we have to do dF dm equals to 0 first, and then d2f dm2. Now tell me it is greater than 0, right? For minimum condition it should be greater than 0. From these two conditions we can get the value of m. That we have to match here. Do you got the point? Simply we will put dm equals to 0. Then we will have some solution of m. Then again we have to put the d2f dm2 greater than 0. This condition will give a specific value of m. And we have to calculate which one is the specific value. Okay. I can do maybe the first one also. What is that? AM square minus center. Why we need the two conditions? Because you can see here two unknowns are there. So obviously we need two conditions. So df dm am minus dm2 plus m5, that will be 0. Then see a minus b n square plus n to the power 4 equals to 0. Then there will be the relation from that. Again, d2f dm2 will be there. Okay. Then you can see the value of m, and you have to see that which one would be the minimum value of m to satisfy this condition, d2f dm greater than 0. I think you can do that, or I have to do, because the time is over. So that can be a homework for you, right? Simply, I already told you what is the procedure. df dm equals 0, put 0, then d2f dm2 equals to greater than 0. Then from that we can have the value of m. They are asking the non-zero value of magnetization, above which the minimum of f will be at a non-zero value of magnetization in which condition. That is the thing. If it will not be done, then we can talk with the ratios also. Okay, so maybe we can stop here and then we'll meet in the next class. Yeah, tell me.
Excuse me, ma'am.
Yes, yes, tell me.
In the symmetry matrix, there someone asked
Huh.
to find the eigenvalue.
Yes.
So I also tried, but I'm not getting the 0, 0 trace.
Okay. So what you are getting? Where it is? Here, I think, yes.
So I'm getting like 31.54 and minus 9.64 and minus 6.89. So sum of the eigenvalues is equal to trace of this matrix. But
Is it the reason for that minus one? But it should not be that one. Okay, I have to check and I will tell you in the next class, okay? Because whatever I did as a symmetric matrix, always it is given the eigenvalues as 0, 0 at the trace of the matrix. But in that case, you told that. Okay, what is the determinant here? Let me calculate determinant quickly. 69. Okay, that would be a very big one. Minus, then minus. Okay, this one will be minus. Trace should be 0. Sorry, determinant. Is it not the 0 one? 13 into 12 plus 40. Then minus 14 into 30.
No, it's plus 14 into because minus into minus will become
No, like everyone is doing determinant differently, but yeah, fine. The answer should be same. Okay. What was that? I forgot. Sorry. What was that? 4, I think. What was that? 4. Okay. No, 4 is this minus this, then minus 14, this, plus 14.
No, I just told you the second term should be
This one, no? No, this one is correct. Like I am doing with this respect. See, this one into this one minus this one into this one. Then this one will be plus 14, but when I mean plus b, and that b is minus 14. So minus 14 is there. Then 13 into minus 12. So minus something. Then minus plus 14. Obviously, it is different to different perspective. Okay, but answer should be same. Okay. Just check your answer, it should be same as mine. Then minus into 13 plus this. This should be the determinant.